This video presents a learning-based approach for task-oriented grass stability assessment. Robotic manipulation tasks often fail due to the sensory and object uncertainties. Therefore, it is essential to predict the grass stability before a manipulation attempt. In addition, the prediction result should be task-oriented. Here we see two examples of the manipulation tasks, where the lifting task succeeded and the rotation task failed, while grasp location and the grasp force are the same in both cases. When grasping deformable objects, such as plastic cups or containers, we need to consider additional conditions for grasp stability assessment, such as whether the object will be damaged or the content of an open bottle will spill due to an excessive deformation. To address these issues, we use a learning-based approach for grasp stability assessment. However, it is very expensive to recollect the data or retraining the underlying model for different tasks. Therefore, our solution is to divide a manipulation task into subtasks, which are defined as modular tasks in this work. The modular tasks comprise of basic operations such as lifting, rotating, and holding the object while the content does not spill when it is open. In this work, we aim to learn the stability of 4 modular tasks based on features acquired before the task execution. By combining the modular tasks, the stability of multiple sophisticated tasks can be estimated without recollecting the data or retraining the underlying model. For instance, for lifting up a rigid or a closed object, only the lift up task needs to be considered. If we want to lift up an open bottle, we should consider the task lift up and the task holding where the content does not spill. For pouring water from a soft plastic bottle, all 4 tasks should be considered. To predict the success rate of a task execution, we use a decision forest as classifier, which is trained for each modular task independently. In the testing phase, the predictor of the main manipulation task assesses the stability of all relevant modular tasks. If one modular task is predicted to be unstable, the main task will be considered to fail. In this work, we use a parallel gripper for all manipulation tasks. We attach a RGBD camera on top of the gripper. The captured point cloud data is used for both object localization and grasp stability estimation. In addition, we mount a tactile sensor on one gripper finger to obtain the tactile reading, which is pressure distribution of the contact. The features we use in this work consist of 3 parts. The first one is the grasp location extracted from the point cloud data. We first estimate the height of the object from the point cloud, and then the grasp location is normalized by dividing it by the object height, such that it becomes invariant to object scale. The second feature set is extracted from the object deformability, which is estimated by the object deformation and the squeeze force. Finally, we extract analytical features from the tactile sensor readings, include contact area, friction-weighted pressure center, and the estimated maximum frictional force and torque. The last 2 features are estimated because of the uncertainty of the friction coefficient. In this work, we approximate the friction coefficient conservatively to avoid false positives. Now we show the experiments and the results. For the first experiment, the main task is to lift up a closed bottle. Therefore, only the lift up task needs to be considered. First, the object is scanned to obtain the point cloud data for the whole bottle. The robot arm moves vertically because of the limited field of view of the RGBD camera. The estimated height of the object is shown as a blue sphere in the point cloud view. Then, after the object is grasped, the features are extracted and used for stability estimation. In this case, the task lift up is predicted to be unstable, and we see that the main task failed. The second experiment is to lift up an open bottle. 2 modular tasks are considered. We see a top view of the bottle and the contents spilled. Therefore, the main task failed. Thank you very much for watching this video. For further information, please visit our website.